First, a little reminder, parallel lines are lines that have the same slope. They will never cross. The lines will always be growing at the same rate, and that is why their slopes are the same. So keep in mind, we have this notation that looks like two vertical lines, and that means parallel. So when we have parallel lines, the slopes will always be the same. So you might see something like this, where it'd be like AB is parallel to CD. That tells us those two lines, AB and CD, are never going to cross. They're parallel. And now we know algebraically they're going to have the same slope. Perpendicular lines, those are lines that cross at a 90-degree angle. And what we found in our investigation is that when you have perpendicular lines, they are going to have opposite reciprocal slopes. So opposite means one will be positive, one will be negative. Reciprocal is when you have a fraction and you flip it. So what was in the top becomes the bottom, what was in the bottom becomes the top. So what we discovered in our investigation was that when the lines were perpendicular, their slopes had opposite reciprocals. Remember this symbol here that looks like an upside down T, that means perpendicular. So you might see something like AB is perpendicular to BC, and that's going to tell you that they meet at a 90-degree angle. But now we know for our coordinate geometry that their slopes will be opposite reciprocals. All right, we're going to make a little bit of a table here. And on the left column, I'm going to give you a slope. The middle column, we're going to talk about what the parallel slope would be. So what would be the slope for any line that's parallel to this one? And then what about for perpendicular lines? Our first entry into this table is, what if the slope is 1? That was one of those instances that we investigated in the Desmos activity. Any line that is parallel to this line that has a slope of 1 will also have a slope of 1. Remember, parallel lines have the same slope. And if I find the opposite reciprocal of 1, since 1 is positive, the opposite would be negative. And then anytime I have a whole number, I can think of it as a fraction by putting it over 1. So really you would have 1 over 1. But when I find the reciprocal of that, it still is just 1 over 1. So the opposite reciprocal would be 1. My next slope that we investigated in the Desmos activity was 1/3. Any line that's parallel to this line that has a slope of 1/3 will also have a slope of 1/3. Any line that's perpendicular to this line that has a slope of 1/3 would have an opposite reciprocal. So since 1/3 is positive, the opposite reciprocal would be negative. And if I take 1/3 and I flip it upside down, 3 will go in the top, 1 will go in the bottom. That's the reciprocal. And anytime I have a fraction where the denominator is 1, I can just write it as a whole number. So this would be -3. So 1/3, if the slope is 1/3, the opposite reciprocal would be -3. The last one we did in the Desmos activity, the line had a slope of -3/4. So any line that's parallel to that line will also have a slope of -3/4. And any line that's perpendicular to this one, we're going to do the opposite reciprocal of -3/4. -3/4 is negative, so the opposite reciprocal will be positive. And then we just flip the fraction and we would get +4/3. It will be helpful if you just leave your slopes in fraction form, so then you can identify much more easily what are opposite reciprocals and what aren't. Let's generalize this though. So if my slope is m, then the slope of every line that's parallel to that will also be m. And the slope of any line that's perpendicular to that, if m is positive, it's going to be negative, or it'll be the opposite sign of whatever m is. And then it would be 1/m. This is the opposite reciprocal. we're going to be using slopes in our coordinate geometry to help us prove that shapes on a coordinate grid are whatever specific type of quadrilateral they might be. So maybe we look at the shape and we say, hey, that looks like a square. The way that we're going to prove that it's a square is by finding the slopes of all of the sides. And then if those slopes are opposite reciprocals of each other, we know that those side lengths meet at a 90-degree angle. And then we'll also be using our slope triangles to help us find the length of a side, because our slope triangle is just a right triangle, and the line is on the hypotenuse of that right triangle. And if I use the Pythagorean theorem, I can find the length of any given line using the legs of the slope triangle to help us. So when it comes to coordinate geometry, we're going to be using the slopes of the side lengths because they'll be on a coordinate grid, so we can use the slopes. And we'll be using the Pythagorean theorem to help us find the lengths of the sides, and that will allow us to classify what shape it is.